These are the answers for exercise 12.5. So question A says, one of the triangles is not similar to the other two. Name the pair of triangles which are similar to each other, giving a reason for your answer. Name the triangles so that the corresponding vertices are in the same order. Alright, so we have these three triangles, and what we need to remember was the two reasons for similarity. The one, or not reasons, but what does that tell us about the two triangles? They are either the corresponding angles are equal, or the corresponding sides are in proportion. So those two reasons. So if we look at these three, we see that we've got these two angles, and given that this angle is 68, this one's 68, and here we also have a 68. But then the second angles, this one has a 37, this one has a 37, but this one has a 65. Now we know that if these two angles are equal in these two triangles, that we can conclude that the third angle will also be equal. So therefore we know now, we naming the first part, naming the pair of triangles which are similar. This part is ABC, triangle ABC is similar, and we're going to name it in the same order. Which one is equal to A? That would be angle R. B is the 68, so that's P, and then C is equal to Q. Alright, so what is our reason for similarity? The reason is that the corresponding angles are equal. Then for B, so now we're going to follow the same procedure. We have a 48 degrees, and we don't see a 40, we see a 48 over here. Then we see 65, 56, but we don't see it anywhere else. So there's none of these that look similar. So that means we're going to have to find out what is the third angle for this one, or even this one. Let's start with the first one. So we have 180. So to work out C, 180 minus 48 minus 56, that gives us 76. So this is 76 degrees. And here we see that this one is also 76. There's a 48. So this must be then 56 degrees. If two of these angles are equal to two of these, the third one will also be equal. So our two angles that are similar, as you can see, none of these other two angles contain a 65 degree angle. So that means triangle ABC is similar to triangle, and in this one we've got A being 48, so that's going to be Z, and then B is 56, so that's X and Y. And once again, our reason is that the corresponding angles are equal. C. Alright, now here we're given sides. So now we're going to work with proportional sides. Now if we look at these, we need to find sides that are in proportion. So if we look at 2, 4, and 5, in the order from smallest to largest, let's look at this triangle from smallest to largest. We've got 3, 4, and 6. So if I have the smallest side over this one smaller side, I have 2 over 3, and then the second smallest would be the 4 BC, so that's equal to 4 over this one's second smallest is also 4. So this proportion is not equal to each other. So let's move on to this one. Over here, our smallest one is 4, then 8, then 10. So let's look at putting AC over this one's smallest one, which is 4. So that's going to be 2 over 4 equal to, then the second biggest, we've got 4 over 8. And both of these proportions are equal because this is a half and that is a half. So that means since they're proportions, and we can see that this 5, double that, gives us also 10. So these two triangles are then similar. So we have that triangle ABC is similar to triangle. Now our proportions was that AC over this XZ. So this is going to be then XZ, and then from there we had CB, so this one, the Y would be last. Alright, then once again, or our reason this time is that the corresponding sides are in proportion. Alright, now for these three, over here, let's look first at our hypotenuse side. We have, okay, this one we don't have the hypotenuse. Here we have, and with this one we don't have the long side. So in this case, we can work out some of these sides. We have that this side would be equal to the long side squared, or the square root of the long side squared. Just take that, the square root of the long side squared, which is 5 minus the other short side. We're using Pythagoras now, 3 squared. So this is equal to 4, right? And solving this one would be 10 squared minus 8. So that's 6. And then this one would be the two of them added together. So that's the square root of 10 squared plus 5 squared. So this one is then 5 square root 5. Okay, so these two seem more likely. If I flip this one around, just in your mind, like maybe draw it like this, where our 6 is at the bottom here. So we have this as D, and then this as E, and this as F, just so that it looks more in the same, more like this one, or in the same order. We have 6 over here, we've got 8 over here, and our hypotenuse 10. So I can see that 3 times by 2 gives me 6, 4 times by 2 gives me 8, and 5 times by 2 gives me 10. So those two are then in proportion to each other. So that means that triangle ABC is similar to triangle, and in that same order, A is down here, then B, so it's going to be DFE. DFE, my reason being the corresponding sides in proportion. Right, so now for E, so over here I've got, let's see if we can quickly look at this. Here we've got a 5, that 10 is doubled, but nothing else seems to be doubled. If I look at this 5 and I double it, I get this 10. Then if I look at this 7, I double it and I get that 14. And then this 8, I double it and I get that 16. So therefore we could easily spot these two triangles being similar to each other. So this is then going to be triangle ABC being similar to, now these triangles are actually rotated so that their proportional sides are at the same side. So here we can easily see that if I said A, B, C, then I can go Y, X, Z. So triangle Y, X, Z. My reason, corresponding sides in proportion.